Hey there, another video coming out. This is again 2013 May Math paper 1 time zone 2. Okay, this is again a section B question. This is already number 10. Okay, this is quite a long question, and I can tell you this is quite tricky. On the other hand, there are little calculation that you need to do. If you understand the principle or the concept clearly, there isn't much you need to do. So I believe this is the big direction of IB right now, especially after the syllabus change from 2014. They will stretch a lot on the application and the concepts and have a little bit less emphasis on the heavy calculation. So let's look at this question. This is really fun. They give you three functions, they define three functions, f, g, and h. While they, instead of giving the function itself, they simply give you some value. They give you the value of f and g when x is 2 and 3. They also give you the value for the derivative. And for h, they give you the second derivative. This is amazing, And part A is really just a give, just give off. What is g3, right? So g when x is 3 is negative 18. You just write down negative 18. Okay, f prime 3 is 1. H double prime 2, negative 6. Okay, so that's it. 3 marks for free. I tell you what, 3 marks for free. And next, in the graph it shows two curves. It would be the curve of H. So this is H, and also the graph of H double dash. Alright, so H prime prime, which is the second derivative. The question is as follows. There is a point of inflection on the graph of h at p when x equal to 3. The question is why? There is no calculation. They do not want you to find the point of inflection. You just need to explain why it is the point of inflection. So you think about normally, how do you find point of inflection, right? If you remember point of inflection, you find it by doing first the second derivative, so double prime, and then you would solve this equal to 0. So this is what you normally do if they ask you for point of inflection. After you get a solution, so let's say the solution is x0, right? So let's say you got x0. What you need to check is whether this is actually a point of inflection. So you would do a side table usually. So for x, you would do x0 in the middle. This is normally the format that I use. You may use something different, but really the point is looking for a side change. So you would want to plug the values into double dash, and you would want like a positive negative or a negative a positive. So you want a side change. So given this, if you have this concept in your mind, this is all you need to write down. Or why? Why is x equal to 3 the point of inflection? First of all, because it would fit. It would fit h double prime 3 equal to 0. Why? Simply from here. So the first thing you write down is since h double dash 3 equal to 0. Next, you need a side change. Where can we find a side change? In the table, we cannot see that because we do not have any value for h double dash before 3 or after 3. You may say, okay, 2 is at negative 6, but what about after 3? It would happen that we see from the graph. In the graph, we see the graph of h double dash. Look at 3. Before 3 is negative, after 3 is positive. So you write this down. Also, there is a side change, okay, of the double dash at 3. And that's it. 1 mark, 2 mark. That shows that P is a point of inflection. That's it. No calculation still. Okay, nothing is done. Okay. Next, part C is given that h will now equal to fx times gx. First question is find the y coordinate of p. So remember that p is when x equal to 3. So like p, the y coordinate of p must then be h3, which you change x to 3, so you have f3 times g3 F3, you can just look at the table on top. F3 is 3. G3 is negative 18. Paper 1, you need to do this calculation on your own, negative 54. Next, this would be the hardest part of this question. This is a 7-mark part. Quite a lot is to be done. So let me get more prepared, get me more paper, right? More space to do this question. The question is, find the equation of normal, okay, to H at P. So how do you find the equation of normal, right? First of all, what is a normal? You need to totally get this clear. You know, this is the graph of H, okay? I roughly copy this from above, okay? You can see the graph. Okay, let's say this point is P, all right? At any point, you can draw a line, which is called the tangent to the graph, which is a straight line that touches the graph at one point. While the normal would be the line perpendicular to this tangent. So this is your normal. So you're looking for the equation of this line, the normal. And as the normal is a straight line, you should know that all straight lines have the equation y equal to mx plus c, where m is the gradient of the line, and c is the y-intercept. So first job is always to find the gradient first. To find the gradient of the normal, it would help if we have the gradient of tangent. And to find the gradient of the tangent, yes, we do calculus, we do integration. So to find the equation of, to find the gradient of the tangent of h, we want to differentiate h. This is the hardest part of this question now. Now h is given to be f times g. So how do you differentiate this, right? Now what you do not do, okay? What you do not do is thinking that h prime x, which is derivative of x, is f prime x times f prime g. This is totally not true. Do not do this. Okay, do not. Why? This is a concept thing. Two things multiplied together, how do you differentiate this? You use product rule. So do you still remember product rule? Product rule says if you have two things multiplied together and you want to differentiate it, although it doesn't matter, you differentiate the first one first, keep the other one, plus differentiate the other one, then keep the first one. This is product rule. Since this is an addition, you can swap this order, it doesn't matter. But anyway, this is the correct way. Do not just differentiate both of them. This is no good. And now, of course, you want the value of the gradient when x is 3, so you plug 3 in. So x prime 3 equals to f prime 3 would be, you find it from the top, f prime 3 is 1, g 3 negative 18, g prime 3, right, negative 3, and then fx3 is 3. So this is negative 18 minus 9, negative 27. Okay? So this gives the gradient of the tangent. So this have gradient negative 27. Okay? But we are looking for the normal. Normal is perpendicular to the tangent. So what we have is if we multiply the gradients together, okay, sorry, it's here. If we multiply the gradients together, we should get negative 1. This gives m equals to negative 1 divided by negative 27, which is 1 over 27. So that gives you the gradient of the tangent. Of the normal. Now we plug this back into our equation of straight line. So y equals to 1 over 27x plus c, where c is the y-intercept. So it wouldn't be clear what is the y-intercept from the graph. We simply can't find it in this way. So to find c, okay, which is a very normal step, would be we plug in the point. It's actually found in part C that for h, when x is 3, y is negative 54. This is where we use this, so we plug this in. Y is negative 54, so negative 54 equals to 1 over 27, x is 3, plus c. Okay, so let's simplify this a little bit to find the value of c. So negative 54 equals to 1 over 9 plus c. C would then be you minus the 1 over 9 to the other side, minus 1 over 9. Okay, this fraction is a little bit big. We may need to do something to simplify it. Okay. This would be negative 489 over 54. Over 9 minus 1 over 9, which is minus 487. And that gives the equation. Therefore, the equation is y equal to mm is 1 over 27. 1 over 27 x minus 487 divided by 9. And that's it. After this, I would say this is actually quite long. You can see the whole solution here. Okay. Well, you miss anything, just rewind and check the video again. But this is the idea. Okay, they give you 3 marks for 3 at the beginning. They ask you what is the point of inflection, still no calculation needed. You just need to be sure, you need to be clear how point of inflection is found. Okay, it's totally because the second derivative is 0, and also there's a sign change shown in the graph. Lastly, alright, the big boss, the equation of normal. The equation of normal means you have to find the gradient of the tangent. To find that means you need to do differentiation. That is, you want to differentiate hx. While to differentiate something multiplied together, you will need product rule. After this, it is just completely normal, standard way of finding the equation of a straight line. I hope this would help. This is a complete breakdown from Kit on this question. So be sure to study this a little bit, and I really believe that this is the trend of the IB, and this is going to come up more and more. Highly conceptual, not much of calculation except a large part. The problem is if you get the beginning wrong, you're gonna blow up the whole thing. So that's it.